High level, what is serverless?
What is serverless? So there's a lot of misunderstanding about serverless, and really serverless is a way of us deploying solutions that don't require that we have to provision our own servers. So we can deploy code that runs, and we focus on the code and the business logic, but we don't have to worry about the underlying server architectures. So servers exist. In order for code to run, it's got to run somewhere. But the important thing is that by following serverless approaches, we don't actually have to provision physical servers. We don't have to provision metal, and nor do we have to provision operating systems onto servers, and we don't have to patch them and update them. We don't have to install software ourselves. We don't have to manage servers. And really importantly, serverless approaches allow us to scale, and scale very quickly in a way that other approaches don't allow us to scale. So we can deploy code, business logic that executes only for the amount of time that it needs to execute on a server somewhere. But that's only one of potentially thousands and thousands of servers that are already running in a shared workspace, running other people's workloads in small, secure, containerized approaches. So those servers exist and are maintained by the cloud service provider like Amazon Web Services. But we don't have to worry about them. Our code is just run when it needs to run on a server that's free and available for our code to run on.
So how does it go on in terms of performance?
Well, performance is actually quite spectacular. Our code runs very fast. If you imagine kind of traditional approaches or more traditional approaches where code is deployed into a container, and the container is deployed into a virtualized container service running on a server, like a Kubernetes pod, it runs at that speed. But we didn't have to worry about all of the mechanics of getting that to happen. We just deploy our code.
So bare metal performance.
Almost.
Comparable.
It's comparable to a virtualized container running on a very high performance compute instance.
So given that this code can run on any server anywhere in the cloud, does that make it more scalable in any way?
Yeah, absolutely. So if we look at services like AWS Lambda, which is probably our favorite service, running a serverless workload means that we get, if we're calling or invoking that code, we'll invoke that code, and that code will be very quickly spun up into a little container, and that container can take a lot of capacity, and it will execute its code, execute across that thread, and we'll then sit there waiting for new requests. And it will sit there for a while before the cloud provider like AWS closes that container down. So you can probably look at around 15 minutes that container will just exist, waiting in case there are more requests.
But you're not paying for it while
but we're not paying
there.
for it. But we're not paying for it while it's not doing anything for us.
Right.
While it's not actively executing our code, we're not paying. But if we get lots and lots of requests all at once, AWS will spin up multiple copies, and within limits, and there are soft and hard limits. But if we look at kind of the core limits,
so that's like multiple versions of your, or multiple instances of your code
all
running in parallel,
Yeah.
all at once, automatically.
Yeah.
Without you having to worry about.
Yeah, we don't know what the capacity needs to be. We don't need to, we don't need to know, within reason. We don't really need to know what our initial capacity needs to be. We can start with one, and that can scale out to thousands. And as quickly as it scales back up, it'll scale back down again. So we're only paying for the actual executions of our code, and only when they actually execute. And if we only need one, we're paying for one. And if we need thousands, we'll pay for those thousands, but only for as long as the code actually needs to execute. And in terms of that scaling, the creation of that initial deployment, the actual startup time, gets referred to as a cold start. So there is a small amount of time, and cloud service providers are improving all the time. But you can, with an initial cold start, we might get a 1 or 2 seconds delay before a container might start, or less. And generally speaking, it's a lot less. Sub-second before our code really runs. And each time we add another container, then we'll get a cold start. But that's, in practice, very rarely noticeable beyond, maybe that first call, there's a slight spinning for a moment, and then off we go. So the scaling is actually very quick and getting faster, is really what I'm saying. And we'll scale up and down as needed. So practically, it's, if we can imagine a traditional service where we've got to work out, what is our likely execution needs, what is our likely capacity requirement, how much traffic are we likely to get. In practice with serverless, most of that is kind of taken away from us. We don't need to worry about that. We just assume, and we can assume, that whatever amount of compute capacity we actually need will be provided to us.
Right. How does it go from a security point of view then?
Well, it's, obviously code is as secure as the developers make that code, and we follow appropriate practices, best practices around security. But it's certainly no less secure than a traditional or more traditional containerized workload running in a virtualized system.
But there's even serverless technologies and approaches for that whole authentication.
That's right.
And security around your data, for example, both in transit and at rest.
Well, we can divide that kind of concept between authentication and the security of the data. So, depending on where we store the data and how we store the data, we can ensure, and we always do ensure, that data is stored in an encrypted form at rest. So that's dependent on the way that we provision those storage components like S3. And the transport of that data in and out of the environments will secure that using API gateway, using HTTPS connections. So we've got data security in flight. So we'll have data security at rest, data security in flight, and then the actual security of the code itself. Our code, although it's running across effectively shared servers, that code's running within our accounts or within the customer's accounts. So we've got some security around that. The fact that code, compute and code and functionality data isn't automatically visible. So we've got that kind of least privilege process anyway, that data isn't automatically visible outside of our account unless we make it be visible outside of the account.
And what about data sovereignty then, in terms of because these compute resources could be anywhere. How do you go about making sure that they're constrained to a geographic region, for instance?
Well, when we say anywhere, I mean really we're talking and we're referring to the region in which those services are deployed. So if we're deploying services in Australia, we'll generally tend to deploy in, for example, AWS AP Southeast 2, which is Sydney. So the data, even though we could be running on any one of many servers, those servers are physically located within a data center in Australia. So we've got data sovereignty that way. It's only when we come to cross-regional data transfer that we have to start to think about where does the data end up.